Welcome to part 2 of our CCNA CCNP Ether channel webinar. When we left off at part 1, we were talking about the two issues we have with spanning tree protocol. The first one we were just chatting about was that one of these two paths is really going to be unavailable to us. STP is going to put one of those two ports in blocking mode on the trunk that we're not going to be using. So that's one issue, is that we have wasted bandwidth. But the other problem is that even though this path over the O12 ports, this trunk is serving as basically a backup path right now, if this port went down on O11 on switch 1, then this one, fast O12, is not going to come out of blocking mode immediately. Bulldogs, you got an idea about how long that's going to take theoretically for that port to come out of blocking mode and go all the way to forwarding mode? That's a good value to know. What do you think? Some of the answer is actually right in front of you. So let's take a look here. First off, we've got to go through a max age, and that is 20 seconds by default. Then we've got to go through two forward delays, because the forward delay value tells us how long the listening and learning modes are. So we're looking at a 50-second delay theoretically. It's going to be between 50 and 55 seconds. And that is a long, long time in our business, isn't it? We don't want those two switches to be incommunicado, if you will, for up to a minute or around a minute. So again, while STP works beautifully, it's obviously very important because we don't want any switching loops in our network. It does have a little bit of a drawback when it comes to these trunks, because we want to be able to use all of these available paths. As much data as we carry through our networks today, especially with voice, especially with video on top of it, we don't want that trunk just sitting there. We want to be able to use all our available paths. By the way, before we get started into how we're going to do that, let me show you another command, show VLAN brief. Just a reminder here, keep in mind that you don't just have one default VLAN, you've actually got 5. And it's a good idea to know that numeric range right there as well. You may never use them in your entire career, but for exam purposes it's a good idea to know. Now, if I told you that this is a 12-port switch, and I promise you that it is, what looks a little odd here? We know that all of our ports are in VLAN 1 by default. That's the native VLAN. It's actually even named default. But what's going on here with O11 and O12? You don't see them here because they are trunking. And you know what a trunk is, but this is where you'll see them, because if an interface is trunking or a switch port is trunking, you are not going to see it in show VLAN briefs output. You're not going to see it there because by definition these ports belong to one VLAN and one VLAN only, but a trunk port belongs to all VLANs. So if it looks a little odd to you and you run show VLAN brief, you're like, I seem to be missing some ports here, some switch ports, run show interface trunk. And again, for your exam, you certainly want to know what the mode is, encapsulation, and status there of trunking, as well as the native VLAN. But that's where you'll see your trunk ports. But what we want to do, we want to use that path, the trunk between the two switches that's running over the O12 port on each switch. And right now we're not doing that. Also, before we get started with the actual Ether channel build here, Bulldogs, tell me this, what is this cost based on? We saw a port cost on each switch that was set to 19. What? Yeah, exactly right. I'm just seeing a couple of the live responses come in here. What we are looking at there, that is derived, I should say, excuse me, from the speed of the port. And that's a good one to know. These are fast Ethernet ports, and they're going to have a default cost of 19. The lower the cost, the more available speed you have. Now, Cisco is not going to ask you on an exam to come up with the exact calculation and how the switch arrives at that, but that's a good default one to know, that a fast Ethernet port is going to have a cost of 19. The other reason I bring that up right now is that I want you to see the impact of the Ether channel on that cost as we build it. Excuse me for scrolling through the study guide for one moment. Those of you who are following along with my study package, and you don't have to, but if you are, just click on the Ether channels link, and we're going to look at a little bit of Ether channel theory here. And then we're actually going to start with the build of one, and of course since it's a lab we can really mess around with it. We're going to tear it down a little bit and run some other little tests that you're not going to see in any book, but you definitely need to see them before you work with them in the real world, and it'll also help you with your exam prep. All an ether channel is the logical bundling of 2 to 8 Ethernet trunks. That's all there is to it. And the term we tend to use here is aggregation, and that may be a new term for some of you. Frankly, it's just a fancy way of saying we're putting stuff together. Okay, all we're doing is bundling these trunks. Now, the ether channels have two tremendous benefits. The first one is when we bundle these trunks, what you're actually going to see is that we have more bandwidth, because that's one reason we're doing it. We're going to have more bandwidth available to us, and that port cost, hopefully, since we're doing this live, we'll see whether it works or not, that port cost should go down. So that's one good reason to run an ether channel. The second one is that the spanning tree protocol considers an ether channel to be one single link. So if any of the physical links inside the ether channel fail, STP will recalculate the port cost, but it will not go through the blocking, listening, learning, forwarding phases, because STP doesn't know that a physical link actually went down. It only sees the ether channel. So I think you'll agree with me, those are two tremendous benefits for our networks, and this is why you see ether channels so often. Now in the example we're going to use in the lab here, and I'll show you this from the study guide as well, we have two switches connected by 3 separate crossover cables. I didn't put the port numbers here for clarity's sake, but what I've done is I've also got a crossover cable connecting the 2 switches at port 10 on each switch. So what we're going to do now is go to the pod and open that particular port, because I shut it down. Remember, your Cisco switch ports are open by default. I shut these down before we began the webinar. Actually, I might have just shut it on that switch 1 side. So we'll run show interface trunk and make sure that we see it, and you do see now that we've got ports 10, 11, and 12 there. Now let's take a look at the impact on show spanning VLAN 1. And you can see that port 010 is still in learning mode, but it shouldn't be there for long. And notice that 11 and 12 now are both in blocking mode. You see the BLK there under status. So now we're in forwarding mode. But now the impact of STP is even more pronounced, because we now have 3 trunks connecting our 2 switches, and everybody tell me, how many of those trunks are we actually using right now? Yeah, we're using 1, and that is a real waste of bandwidth. Never mind the 50-second delay if port 010 on this switch goes down, or neither switch goes down actually, because then 011's got to open on this switch. And remember that on your route, pausing for dramatic effect, let's try that again, shows spanning VLAN 1, on your route all 3 of these ports are in forwarding mode. That's the default behavior on the route. So now we have 6 ports involved, and 4 of them are in forwarding mode. We're going to go back to switch 1, because that's where we're actually going to start building the ether channel here in just a moment. But now you see we've got those 2 unused paths just sitting there, and that's a real waste of bandwidth. So now we're going to start bundling them with the ether channel. We're going to pause here for just a second, and for those of you watching on YouTube and the on-demand site, you can go to part 3 of the webinar next, and we're actually going to start building the ether channel from there.